Welcome back everyone. It's now time to test your new skills with Seaborn with some exercises. In this lecture, we're going to have an overview of the exercise notebook, as well as some special additions and things to keep in mind for the notebook. And in the next lecture, we'll go ahead and go through the solutions. I do encourage you to actually then go through this lecture because this exercise notebook is going to be slightly different than what we've seen in the past. As noted, the main goal of Seaborn is to really be able to just use its simpler syntax to quickly create informative plots. In general, the syntax of Seaborn is so simple that it's actually hard to test on because most of the plots are simply passing in the data frame and then choosing an X and Y. After that, it's pretty much all just personal styling choices. So for these exercises, what we've done is we've inserted JPEG images of Seaborn plots we want you to replicate, as well as a description of what the plot is actually showing and representing. Something I don't want you to worry about though is if you don't get the exact coloring or dimensions exactly the same as ours, maybe we're showing you a scatter plot and you don't happen to choose the same exact alpha transparency value, that's totally okay. Really, what we want you to focus on is what is the general plot type being called and what is the relationship being visualized, and can you more or less replicate that? So something to keep in mind as we're going through these exercises is you should read the plot description very carefully. Pretty much all the plots that we're going to show you here have actually had some filtering and adjustments done first with Pandas on the overall data frame before being passed into the Seaborn call. So to try to challenge your skill set a little bit, we've added in some filtering that you'll have to do with Pandas. So this is going to test both your Pandas skills as well as your new Seaborn skills. Okay, so what we're going to do here is let's go ahead and jump to the Jupyter Notebook and do an overview of all the plot types and what they're actually representing. Okay, so here I am at the Seaborn exercise notebook. Go ahead and run the imports here. We've already filled them out for you. And then you can also read in the data source, and we've already filled that for you as well. It's just pd.read.csv and this application_record.csv file, which is located under the Seaborn folder. And then we check out the head of this data frame. And basically what this data represents is whether or not someone was accepted for a new credit card. And this uses just some personal information for some credit card applicants, and it's actually linked here based off a Kaggle project. So essentially what we have here is a bunch of information for all the people that applied for a credit card. The client ID number, their gender, whether or not they had a car, did they own property, did they have children, what's their annual income, and so on. And then what we're going to do is have you recreate plots based off this data frame. Okay, so each of these plot types, we've tried our best to make it a little more challenging than just calling Seaborn and recreating like a simple scatter plot. So for this first plot, we want you to recreate the scatter plot shown below. You'll notice this scatter plot basically shows days since they were born versus days they've been employed. And it makes sense that this is a more or less linear relationship because the longer you've been alive, more likely the longer you've been employed. So you can see there's kind of this cutoff because you can't really work more days than you've been alive. So that's why you have this linear cutoff. And you should also notice there are so many points that it makes sense to use an alpha value for transparency here. And so we said feel free to adjust alpha in line with parameters to try to duplicate what we've seen here because we have so many points stacked on top of each other. The one thing to note as you explore days of birth and days employed is if you come back here to the data frame, you'll notice that days since they were born and days since they were employed is actually relative to the current date. So essentially you can think of today as 0, and then day's birth represents a negative number, so how many days before today at 0 were they born? So for example, this person was born 12,005 days ago. That's why this is negative. And this person then has been employed for 4,542 days leading up to today at 0, which is why these are both negative. So in order to plot these out as positives, you'll have to figure out how to fix that with Pandas. Okay, so that's the main goal behind this. And again, this is days employed. So we hinted here that you're going to have to actually remove unemployed people from the data set first. So this is a scatter plot only for the people that are employed. Okay, moving on to recreate the distribution plot shown below. You'll notice this distribution plot is going to show the age in years and then the distribution of that. You'll notice if you come back to the data frame that we actually don't have the age in years of these people. All we have is how many days it's been since they were born. But hopefully you can use a little bit of math to figure out how to convert this number into how old that person is in years. So we'll leave that up to you. If you get stuck on that, feel free to look at the solutions. But again, all this is showing then is a simple histogram, and you can edit things like the color, line width, etc. to try to duplicate what we've shown here. Okay. After that, we want you to recreate the categorical plot shown below. And so what this does is this plot is showing information only for the bottom half of income earners in the data set. So right off the bat, you know you have to actually edit the data frame to grab the lower half of the income earners. Many ways you can do that with Pandas. Once you have that, then what we've shown here is the box plot where categorically we're showing the family status, married, widow, single, etc., and then the total income amount. Again, this is for the bottom half of earners. So we've labeled here income totals per family status for bottom half of earners. And then we've also shown this additional hue argument, basically flagging whether or not they own property, yes or no. Then we have this last task to recreate the heat map shown below. And this is a little cut off because of the way we showed it with the markdown, but essentially what we have here is it's just a heat map showing the correlation between the numerical columns in the data frame. And you can get correlation of Pandas by calling dataframe.corr. Okay, and you'll also notice that this flag mobile has a NaN correlation of every other column, so you should probably drop it. And that's how you get your heat map. This one should be probably the simplest out of all the plots. Okay, so that's it. If you get stuck on anything, especially with the Pandas stuff, feel free to just take a peek at the solutions to see what we're doing with Pandas before heading over to plotting of Seaborn. In the next lecture, we'll go over the solutions. I'll see you there.